Okay, in the last lecture we have looked at all the trends and everything. Yeah, all the trends of D block and all that thing we have seen in the last lecture. Okay, now in this PPT, by the way, I have added everything. Okay, I have added everything from the reference book, from everywhere. So it is not necessary that I will go through each and everything. Okay, some of the extra part is also there in the PPT, so you can refer this PPT afterwards also. Okay. Today, what are we going to look at today? Let us look at all the remaining part. Okay, that is your electrode potential, whatever is left, we will look at that. Okay. Okay. Shall in the last lecture we had started with the D block elements. Yes. In the last lecture we looked at your first transition element, second transition series, your scandium to zinc and all that. I guess we did the mnemonic also in the first lecture. Yes, from scandium to zinc. Yeah, everyone, do you remember? Sarjana, isn't it? We did the mnemonic also. We looked at the how to write down the elements, how to remember the elements from atomic number 21 to 30. Yes, we have looked at that also. So it is very important to remember this 3D series maximum where everywhere. Okay, next chapter is a coordination compounds. In that chapter also very important, because in that we are going to study about VBT, where everywhere you will require the atomic numbers. You will require the atomic number. Okay, so it is very important to do that. Okay. So in the last lecture we have covered that. Okay, we have covered all the trends in the last lecture. Okay, so how your atomic radii is there and all that thing we have covered. Okay, today we are going to start with electrode potentials. Yes, electrode potentials. Come on, tell me everyone, what do we mean by electrode potential? Anyone remember? Yeah, that is there in your electrochemistry. Yes. Okay. Okay. Come back over here. If your electrode potential is positive, if your electrode potential is positive or your standard reduction potential is positive, okay, you must have done this in the Nernst equation. Yeah, if standard reduction potential is positive, will it undergo oxidation or will it undergo reduction? Yes, Sarjana and Muldeep, Gopinath, correct. And if your standard reduction potential, yes, is positive, will it undergo oxidation or reduction? It is there in electrochemistry. Yes, will it undergo reduction or oxidation? Yes, we have forgotten electrochemistry, isn't it? See, in the electrochemistry, we have done the table. Okay, we have done the table where all the reduction potentials were given. Okay, so in that, if you remember, all of the values were reduction potential. That means what? Copper value was given. Okay. Tell me this, in the Daniel cell. In the Daniel cell, which were the two electrodes that we used? Yes, what were the metals that we used? Do not say anode and cathode. Which were the metals that we used? Correct. And Anmoldeep, Sarjana, in Daniel cell, which metals did we use? Yes, which metal electrodes did we use? Anmoldeep, Sarjana, Gopinath. In Daniel cell, which two metals that we used? Yes, it was zinc and copper. And which one was undergoing oxidation? Yes, which electrode was oxidation? Which electrode was oxidation? Yes, correct. It was zinc who was undergoing oxidation, which is your anode. Yes, copper was the one which was getting reduction, which was undergoing reduction, and it was a cathode. And look over here, Sarjana, this is your copper. This is your copper. Yeah, so this everywhere this is 0. All of the 3D series metals, okay, they are below zero. Okay, that means what? They are negative. So if you have a positive reduction potential, that means it will undergo reduction. More the positive value, more that reaction will happen, more the reduction will happen. More the positive, more the reduction. More the negative means what? This will be the best. Yes, this will be the best to undergo oxidation. Yes. So if the value is negative of reduction potential, it will undergo oxidation, and hence Sarjana, and we had used copper as a cathode. Why? Because over here copper is the only metal in 3D series in the positive value. That was around 0.34 if I'm not wrong. Yeah, 0.34 potential was there of copper. Okay, that's why we had used copper as a cathode, because only metal with a positive reduction potential, and hence it can undergo reduction. Is it clear, Sarjana? And yeah, Kevin, Ragul has just joined. Good evening, Ragul. Okay, so this is what was there in your electrochemistry. Okay, so we are learning a little bit over here also. Yeah, sure. Let us go ahead. So standard electrode potentials we have already discussed. Okay, what is positive, what is negative. These values are not that required actually. Okay, Nernst equation is there, that also we have discussed in electrochemistry little bit. Okay, so important is trend. Always remember in the trend. Okay, copper is the positive one, hence it can undergo reduction, yes. So your copper reduction means what? Is it gain of electron or is it donation of electron? Yes. Is it gain of electron or is it loss of electron? Reduction. Yes. Correct. Reduction is nothing but the gain of electron. Reduction is nothing but the gain of electron. Yes, it is gain of electrons. Okay. That is a reduction. Okay. So over here Cu can undergo reduction. Okay. Okay. Now in your D block element, okay, all these electrode potentials are given. No need of by hearting the numbers. No need, again I repeat, no need of by hearting this number. Okay, no need of by hearting this number. Only remember the order. Okay, only remember the order. Only remember the order. Just give me a minute, everyone, till you look at this table. Just give me a minute. Okay. So that was the trend of electrode potential. Now you have something called as trends in higher oxidation states. Okay, like if I ask you everyone, which element in the 3D series, okay, I'm talking only about 3D series, okay, which element in 3D series shows the highest oxidation state, yes, which metal in 3D series shows the highest oxidation state, and what is that oxidation state? Which metal shows the highest oxidation state, and what is that oxidation state? Yeah, correct. And yes, Sarjana, look at the table we had done in the last lecture of the oxidation state. In that we had done the common oxidation state, correct? So your 3D series, manganese, okay, Mn shows the highest oxidation state, that is +7. Okay, but in the halides, okay, it is little bit different. In the halides, let me show you the table. Just a minute. Okay, look over here. So we have halides over here. Okay, halide. Halide means what? Your metal reacting with halogen will give you halide. Okay. Now write this down. Very important. In the halides. Okay. In the halides, chromium will show the maximum oxidation state, that is +6. Come on, write it down. In the halides, in the metal halides, yes, in the metal halides, in the metal halides, okay, in the metal halides, in the metal halides, yes, write it down. Chromium shows the maximum oxidation state of +6. Okay, chromium shows the maximum oxidation state of +6, and write it down over there, CrF6, 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 CrF6. Okay, so in your metal halides, your CrF6 will be the highest oxidation state of chromium, that is +6, and manganese will stop at F4 only. Manganese will stop at F4 only. Okay, please remember this. Please remember this. Okay, manganese will stop at +4 and Cr will go up to +6. Okay, done. Is it clear till over here? Okay. Now, but that is not the case with the oxides. Okay, that is not the case with oxides. Now look over here. Suppose I have Mn2O7. Can anyone tell me what is the oxidation state over here? Yes. What is the oxidation state of Mn over here? What is the oxidation state of Mn over here in Mn2O7? What is the oxidation state of Mn in Mn2O7? Quickly. Yes, correct. Correct, everyone. Okay. So in the oxides, okay, it is not like that. Okay. In the oxides, it is not like that. In the oxides, write it down. In the oxide, manganese, your Mn shows the highest oxidation state of +7. Please remember, this has come in exam. In the halide, your chromium shows the maximum oxidation state, and in your oxides, in the oxides, manganese shows the highest oxidation state. Manganese shows the highest oxidation state. Okay, that is +7. Now over here, why does this happen is Mn +7. See, such a high oxidation state requires the stability. Okay, such the high oxidation state requires stability. Now when I go to Mn2O7, okay, Mn2O7, they form a double bond. Okay, like oxygen, okay, Mn2O7, if you look at the structure of Mn2O7, okay, if you look at the structure of Mn2O7, it is something like this. Mn, O, Mn, okay, double bond O, double bond O, double bond O, okay, 1, 2, 3, 4, 5, 6, 7, okay. So this +7 oxidation state, no, this can be stabilized with the help of oxygen, okay. That oxygen, lone pairs you have everywhere. So this +7 oxidation state can be stabilized using oxygen. Hence, yes, it can go up to +7. But that is not the case with fluorine. Fluorine cannot form a double bond, Sajna. Fluorine cannot form a double bond. Over here, your oxygen can form a double bond, and hence your Mn2O7 is possible in the oxides. Hence, your manganese Mn can go up to +7. Mn can go up to +7 in the oxides. Is it clear? Come on, give me yes or no. Anmoldeep, is it clear? Is it clear, everyone? Okay, sure. Let us go ahead. Let us go ahead. Okay, so write down this also, Mn2O7, okay, as an example of Mn +7. Okay, write down the example also as Mn2O7. Okay, write down the example also as Mn2O7. Okay, sure. Let us go ahead now to the magnetic properties. Okay. After this oxides and halides, you have a very important topic, that is magnetic properties. That is magnetic properties. Okay. Magnetic properties. Okay. Now, magnetic property, if I ask you, what do we mean by diamagnetic? Anmoldeep, Sarjana and Prashanti has joined late. What is diamagnetic? Yeah. What is diamagnetic? No unpaired electron. Perfect. So magnetic properties, okay, we have something called as diamagnetic, we have something called as paramagnetic, and we have also something called as ferromagnetic. Yeah. What is ferromagnetic? You must have heard about dia and para. I am 100% sure. Yes, but what is ferromagnetic? Okay. So diamagnetic means what? Anmoldeep, Sajna, it means all the electrons are paired. Okay. All the electrons are paired. Okay. All the electrons are paired. In paramagnetic, there are some electrons, unpaired electrons which are unpaired. That is paramagnetic. Okay. Unpaired electrons are present. That is paramagnetic. Ferromagnetic, write it down, it is a permanent magnet. Okay. It is a permanent magnet. Okay. What happens, this paramagnetic and diamagnetic, it shows magnetic property only when you place it in the magnetic field. Okay. Ferromagnetic is a permanent magnet. Write it down, it shows magnetic properties even after removing from the magnetic field. It retains magnetic properties. Write it down, everyone. I know a little bit theoretical, but write it down. It retains magnetic properties even after removing from magnetic field. Even after removing from magnetic field. Come on, write it down and done in the chat box. From magnetic field. Okay, that is your ferromagnetic. Although it is not required over here, but please write down the definition. You should know this. You should know this. Ferromagnetic means permanent magnet, that it will always behave as a magnet. Come on, write it down and done in the chat box. Write it down and done in the chat box. Okay, shalom. Now you have to calculate the magnetic moment, like how strong your magnetic moment is present. That is a common question in the exam. Okay, is DNF done in the school? Then you should be knowing the formula. Yeah, is it done in the school? Sadhana and Muldeep, is it done in the school? DNF is not there only, no? Oh no, DNF is there. DNF is there. No, DNF is there. We have coordination and we have DNF, if I'm not wrong. In this year's syllabus, E block is not there, S block is not there. Okay, D and F and coordination compound is there, if I'm not wrong. Yeah, it is there, Sarchana. Okay. So, magnetic moment that we calculate in terms of Bohr magneton. Okay, magnetic moment. Bohr magneton is the unit. Okay, so we calculate using, we have found out a theoretical way of calculating it. Okay, that is N. We use the formula N plus 2 everything under root. Okay, that is N is nothing but number of unpaired electron. Please write down the formula. N is nothing but number of unpaired electron. N is nothing but number of unpaired electrons. Number of unpaired electrons, not number of electrons. Please remember this. Many students get confused in this. Yes, it is number of unpaired electrons. Number of unpaired electrons. Number of unpaired electrons. Okay, now let us say I have okay, titanium 3 plus. Titanium 3 plus. What will be my N over here? N is number of unpaired electrons. What will be N over here? Come on, quick. Anmoldeep. Correct. So if I solve it, what will be the answer? N. Yes, Arjuna, what will be the number of unpaired electron? Do not have to be so 1.73 to 1.73 is fine. 1.73 is fine. Okay. So Sarjana, what is the atomic number of titanium? What is the atomic number of titanium? Anmoldeep. Prashanti, what is the atomic number of titanium? 22. Yes, scandium, titanium. So 22. How do we write down the electronic configuration? Yes. How do we write down the electronic configuration? The valence electronic configuration is what you have to remember. Simple. It is 2, no. So 4s2, 3d2. Simple. Yes, 4s2, 3d2. So if I having 3 plus means what? I have to remove 3 electrons, Prashanti. I have to remove 3 electrons. When do you get a positive charge, Sarjana? Positive charge you get when you remove electrons, isn't it? You get a positive charge when you remove the electrons. Okay, so it is 4s0 3d1. It is 4s0 3d1. So I have one unpaired electron. So if I put it over here, 1 plus 2, yes, it becomes 1 into 3 under root 3, that is nothing but 1.73 Bohr magneton. Is it clear, everyone? Sarjana, Anmoldeep, Prashanti, and Gopinath, Ragul. Is it clear? Okay. How will you do this? Oh, chalo, let me give you example. Suppose I have CO2 plus. CO2 plus. Chalo, without my help, quickly tell me the final answer. CO2 plus. CO2 plus. CO2 plus. Correct? Come on, Sarjana, Anmoldeep, Prashanti. Yes. Correct, Sarjana. Yes, Anmoldeep, what will be the answer? I'm waiting for you. Cobalt. CO. What is the atomic number, Sarjana? For cobalt? Yes. What is the atomic number? Correct. It is nothing but 27. So again, as I told you, if you have to write it down, yes, correct. So how will you write down the electronic configuration? 4s2 3d7. Simple. Yes, since it is 27. Yeah. So now I have to remove 2 electrons. So 4s0 3d 4s0 3d. Yes, 4s0 3d 7. 4s0 3d 7. So 1 2 3 4. So over here 1 2 3 4 5 6 7. So how many unpaired electrons I have? I have 3 unpaired electrons, isn't it? I have 3 unpaired electrons. So if I do n plus 2, yes, so 3 plus 2 is 5, 3 5s are 15. So root 15, see, Always remember, root 16 is 4, root 9 is 3. So if I am having root 15, that means it is around 3.9. Yeah, it is around 3.9. Are you getting it, everyone? It is around 3.9. So if you want it accurate, it is actually 3.87. Okay, 3.87. Is it clear, Anmoldeep and Sajna? Okay, so let us do this last one. Come on, tell me. Mn2 plus. Mn2 plus. Mn2 plus. Okay, correct and correct, Sajna. Yes, Anmoldeep, Prashanti, Ragul. Yes, it is what? It is root 35. Correct. So over here, Mn2 plus. So Mn2 plus, Mn, what is the atomic number? We know Mn is nothing but 25. So it is 4s to 3d5. Is it? Is it 4s to 3d5? Yes, correct. So that is makes us 4s0 3d5. Correct. So we have unpaired electrons 5. So 5, 5 plus 2. Correct. So that is 5 into 7. That is 35. That is 35. Under root 35. So under root 35 means somewhere around 5.9. Somewhere around 5.9. And this is a very common question. One question comes. So please do not forget the formula. In the exam, student get confused. Is it n plus 1 or n plus 2? You do not have to get confused. Remember, that is square root. So it is 2. N plus 2. Do not forget the formula. N plus 2. Is it clear? Okay. Now I do have some questions on this. Just a minute. Okay. Okay, look over here. This is your NEET 2018 question. Okay, this is your NEET 2018 question. Come on, do it quickly. I hope it is visible. NEET 2018 question. Correct. And you always check for exception, that you have to solve minimum amount of questions. Okay, check the options and then go and solve. Check for options and then go and solve. Like for example, look over here. If you solve the fourth one, if you solve the fourth one, Ni2 plus, do you have to solve other three? Yeah. So do not sit and solve from beginning. Okay, check the options. Okay, this one is exception. If I get one answer from this, I'll get the complete answer. Look at the fourth one. All four options are different. All four options are different. Are you getting it, everyone? So always look at the option and then solve it. Do not solve everything. Like I get it that you know the concept. That does not mean like if you solve all the 4 questions, will you get extra marks? Yes, Arjuna? No, na? We will not going to get extra marks. Yes, we are not going to get extra marks for good handwriting. Neither we are going to get extra marks for solving everything. Yeah. So you have to be smart with the hard work. You should know the smart work also. Okay. Do not waste your time. Very, very precious. Okay. Correct, Sarjana. So just solve for Ni2 plus. You'll get your answer. Anmoldeep, I'm waiting for your answer. Just solve for Ni2 plus and you'll get your answer. Prashanti, you have not given any answers today. What happened? Yes, Na2 plus Anmoldeep. What will be the answer? Come on, solve it. Nickel, if you do not know, I'll help you. It is 28. So it is 4s2 3d8. Yes, 4s2 3d8. Okay. So if I see the 2 plus, it is 4s0 3d8. Now I need the unpaired electrons. Correct? I need the unpaired electrons. So over here 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So 2 unpaired electrons. Did I do anything wrong? Just a minute. Nickel is what? Nickel is half. So 2 unpaired electron, correct, Anmoldeep? 2 unpaired electrons, so that makes us 2, 2 plus 2, 4, 4 to the 8. Yeah, 4 to the 8, under root. Yes, under root 8, that means 4 should be 1. So that is here, you have got your answer. Is it clear? Prashanti, Anmoldeep, Sarjana, and you have to be smart. Yes, do work hard, but do the smart work also. Okay, then now come on, do this. NEET 2020 question. See, every year one question from this is very common. Come on, do this now. Easy. Okay. One on Muldeep, I expect an answer. Correct, Sarjana. Correct person, C, correct on Muldeep. Okay. Hey, fine. Romeo, what is the atomic number? Atomic number is 24. So it is 4s1 3d5. 4s1 3d5. So if I remove the 2 electron, it becomes 4s4 3d4. Yes. So always remember. See, look over here. So if n is equal to 1, what is your value? If your n is equal to 1, yes, it is becoming 1, 1 plus 2, that is under root 3. Yeah, under root 3, that is close to 1.79. Yes, if your n is equal to 2, what is the value you will get if you have n is equal to 2? So 2 plus 2, 4 root 8. Yes, it will be root 8. So root 8, yeah, 2, that is again close to something 2.87 or 2.84. Yes, if n is equal to 3, yes, it will be 3.87. If n is equal to 4, that now just now we have calculated, it is 4.9. If n is equal to 5, it is 5.9. Yes, n is equal to 5, it is 5.9. Please do not even solve everything. Okay, look over here. Just look at the unpaired electron. See, if you have one unpaired electron, answer will always be in 1. If you have two unpaired electron, it will be in the 2. If you have 3 unpaired, it will be in the 3. If you have 4, it will be in 4. If you have 5, it will be in 5. That's it. Do not even solve it. Even if you do not know the formula, still you can remember this. Are you getting it? Anmoldeep, Prashanti, Sarchana, and yeah. Even though, let's say you have forgotten the formula, but you know you have unpaired electrons over here. 1, 2, 3, 4, 5. So the start will always and always be the same. Okay, the start will always and always be the same. Is it clear? And Prashanti, Sarchana, is it clear? Okay. Now come on, do this as the last one, then we'll move ahead. Do this as the last one, then we'll move ahead. Okay, do this as the last one, then we'll move ahead. Okay. Yes, Sarjana, Anmoldeep. Prashanti, what will be the answer? Correct, Sarjana. Everyone who will write the answer, please click on my name Anmoldeep. Okay. Do not send it in all chats. Click on my name. Okay. And then send the answer. Click on that all chats option, click on my name, and then send the answer. So over here, what are they asking? They want the minimum paramagnetic behavior. Yeah. They want the minimum paramagnetic behavior. Paramagnetic means what, Prashanti? Paramagnetic means you have unpaired electron. When can you have minimum paramagnetic? When you have minimum number of unpaired electrons. You do not have to solve anything. Straight ahead it is given everything. You have Cr2 plus. Yes. They have even given you how many d electrons you have. Yeah. They have even given you the d electrons. Yeah. They have even given you the d electrons, isn't it? They have even give you the d electrons. Correct. Good evening, Sindhuja. Yes, they have even given you the d electron. D orbital electrons. Okay. So d4, that means what? You have 4 electrons. So 1, 2. So if I have d orbital, correct, d4 will be like this. 1, 2, 3, 4. So 1, 2, 3, 4. Correct. This is your d4. That is Cr2 plus. Correct. Then you have the d5, that is Mn2 plus. Again we have 5 unpaired electron. It will show the maximum. Then we have Fe2 plus, which is d6. D6 means what? 1, 2, 3, 4, 5, 6. 4 unpaired electrons, 4 unpaired electrons, 5 unpaired electrons. Yes, but in the D7s, Prashanti, Anmoldeep, in the D7, yes, in the D7, how many unpaired electrons we have? 1, 2, 3, 4, 5, 6, 7. We have only and only 3 unpaired electrons. We have only and only 3 unpaired electrons, and hence it shows the minimum paramagnetic behavior. Is it clear? Anmoldeep, Prashanti, and Sajna, Prashanti. Is it clear, Sindhuja? Okay, chalo. Then let us go ahead now. Let us come to color. Yes, let us come to color. Yeah, color. How do we see color? Yeah, I know the physics explanation. Light falls on our retina. Yeah, then we see the light, we see the color. But what about our chemical compounds? How are they colorful? How do they get color? Your chemical compounds. Yes, what is the necessity? Like, what is necessary thing for the compound to get color? Yes, what is the necessary thing to get for the compound to get a color? Are you getting my question? Without that, your compound cannot have color. Yes, what is necessary for a compound to have a color? Yes, for a compound to have a color, what is necessary? Okay, I'll share one table of color. Look over here, everyone. Look over here. So I am sharing a table of colors. Observe the colorless. Observe the colorless. One, two, three. One, two, three. What is common in all of them? Correct, Sindhuja? What is common in all of them? Yeah. What is common in all of them? Correct. And yes, what is common in all of them? Anmoldeep, observe. Colorless, colorless, colorless. What is common in all of them? Yes, Sajna, what is common in all of them? Yes, the common thing is they do not have unpaired electrons. 3d0, 3d0, 3d10. No unpaired electrons. And for the color, it is very important that your compound should contain unpaired electron. What happens? It absorbs light, goes into higher energy level, come back into, again relaxes and come back into lower energy level by emitting some wavelength of light. And that we see as a color. Okay, hence it is very important for your compound to have unpaired electron to show the color. Okay, so I want you to do one thing, take it as homework. Okay, take it as homework. Write down all the colors over here. Okay, like for example, write down violet. Okay, and write down which are the elements or which are the metal that are violet. Okay, so write down violet, and these three are violet. Your vanadium 2 plus, chromium 3 plus, and Mn3 plus. Like, are you getting it, everyone? Okay, important. So on the basis of color, just bifurcate them. On the basis of color, just is it clear? Is it clear, everyone? Because in the exam, generally logical question will only come. They might ask you color, colorless. Okay. For example, look at this question. Look at this question. Look at this question. Okay. Look at this question. Try to attempt it with the same logic. Try to attempt it with the same logic. Correct, and yes, Prashanti, Sindhuja, Sarjana. Yes, Yes, Arjuna, Anmoldeep, Sindhuja, correct Sindhuja. Yes, what is required? What is required for a color? Yeah, you need unpaired electron for color. So for colorless, if you do not have any unpaired electron, it is colorless. Yes, scandium. Yes, scandium. Scandium atomic number is 21. So if I write down the electronic configuration 4s2 3d1, if it is plus 3, that means 4s0 3d0. And just now we have seen 3d0 is nothing but what? 3d0 is colorless. 3d0 is colorless. Is it clear? Sarjana, Anmoldeep, Pransti, Sindhuja, and is it clear? Yes, very easy, very scoring. Do not lose marks in this. Color and your magnetic moment. Okay, they will definitely one question is expected. So do not lose marks in this. Okay, easy part. Okay, not so theoretical also. Easy part. So do not miss the marks in this. Okay, sure. Let us go ahead. Okay. Okay, sir, let us take a break. What is the time? It is 58. Yeah. Catalytic properties. Okay. Catalytic properties. Now, you must be aware that, what are catalysts? Sajna and Sindhuja, what are catalysts? Yes. What are catalysts? Yes. What do we mean by catalyst? Yeah. What do we mean by catalyst? It fast a chemical reaction. What does that mean? It fasts a chemical reaction. Yes, what is a catalyst? And Sajna, we can say it increases. Yeah. Basically, the actual definition is it changes the path of the reaction. Yes, it alters the path of the reaction. It increases. So we can roughly say it increases the speed or increases the rate of reaction. Yeah, we can say that, isn't it? Increases the rate of reaction. Yes, very important, without taking part in the reaction. Now, what is this without taking part means? Like, it does not show any reaction with any reactant, is it? What is the meaning that it does not take part? What does that actually mean? Yeah, like you are just adding over there and it just speeds up. What is that without taking part? What is the meaning of that? Yes, Ajna? It increases the rate of reaction, increases the speed of reaction without taking the part in the reaction. Yes, Induja, Prashansi, Ragul. What does that mean? Without taking part in the reaction. Yes, without taking part in the reaction. It does not react with reactant to form compound. What if I say yes, it does react? It does undergo reaction. It can undergo reaction. See, without taking part, the meaning is what you have put, let us say you have put 2 gram of catalyst. Okay, it will come out as 2 gram again. Okay, no matter what reaction happens in the adjacent steps, okay, 2 3 steps, whatever happens, but in the last step it will come back as 2 gram again. Okay, it comes back again as the 2 gram. That is without taking part. Okay, so most of the d block elements, they are catalyst. Yes, they are catalyst. Like for example, iron. Yes, how many of you remember Haber's process? What do we prepare? Sajna and Sindhuja, what do we prepare with the help of Haber's process? Anmoldeep. Yes. What do we prepare with the help of Haber process? What do we prepare, Sarjana? You look tired today. What happened? Too much of school? Came late? Yes, correct. In the Haber's process, we prepare ammonia. Yeah. So what is a catalyst? What is a catalyst in Haber's process? And Sindhuja, what is the catalyst in the Haber's process? Haber's process is nothing but N2 plus H2 gives you ammonia. Yeah. Yes, the Fe is catalyst. Fe is used as a catalyst and MO is the promoter. Correct. Fe is used as a catalyst. Fe is used as a catalyst. Correct. Fe is used as a catalyst. Similarly, in some of the reaction, even Fe3 plus is used as a catalyst. Even Fe3 plus is used as a catalyst in some of the reaction. For example, look over here. For example, if I react, okay, if I react S2O8 2 minus, does anyone know what does this S2O8 2 minus means? Yes, S2O8 2 minus, what is it? Yeah, it is peroxodisulfate. Remember, it is peroxodisulfate. It is peroxodisulfate, or it is also called as persulfate. Okay, it is also called as persulfate. Okay, it is also called as persulfate. Okay, persulfate. Okay, so I have iodide. Okay, I have iodide and persulfate. Now this reaction, whenever we react iodide and persulfate, what happens is iodine gas is released and the sulfate ions are given out. Okay, iodine gas is released and we get the sulfate ion. Now in this, okay, this reaction is very difficult, but with the help of our Fe3 plus, yes, with the help of our Fe3 plus, these reactions happen easily. Okay, now I am coming back to the part where we have said it does not take part in the reaction. Now how does Fe3 plus work over here? How does Fe3 plus work over here? Look over here, then write it out. So what happens is Fe3 plus first reacts with your iodide. Okay, Fe3 plus first react with your iodide. Okay, so and it does undergo reaction. It is not like it does not undergo reaction. It can undergo reaction. Okay, so Fe3 plus, it reacts with iodine, okay, or iodide to give you Fe2 plus plus iodine gas. What you needed. Okay, plus iodine gas is what you have got. Fe3 plus to Fe2 plus. Is it oxidation reduction? Sarjna, Prasansti, and yes, Ragul, Anmoldeep. Fe3 plus to Fe2 plus. Is it oxidation or reduction? Yeah. Fe3 plus to Fe2 plus. Is it oxidation or reduction? Fe3 plus to Fe2 plus. Yes, it is nothing but reduction. Perfect. It is reduction. Now, over here, yes, your iodine gas you have got. But Fe2 plus is not your catalyst. What is your catalyst? Your catalyst is Fe3 plus. You do not want Fe2 plus again. Yeah, so what happens? Your Fe2 plus, now remaining Fe2 plus, it reacts with your persulfate ion. Okay, so Fe2 plus, it reacts with persulfate ion, and again it comes back to Fe3 plus and your disulfide. Are you getting it, everyone? Yeah, so this is how, okay, this is how your Fe3 plus has again come out as it is, and that is what I'm saying. It does not, catalyst does not take part in the reaction. What does that mean? That does not mean it does not undergo reaction. It undergoes reaction. It reacts with the reactant, but in the last step it will come outside as it is with the same amount. Okay, that is catalyst, and this is the example. Come on, write it down quickly. Write down both the reaction. This is how catalyst work. Come on, done in the chat box. Write it down. Sajna, is it done? Okay, sure. Let us go ahead. go ahead. Okay, this was your catalyst, how your catalyst work. Okay, then we have something called as interstitial compound. Interstitial compound. Interstitial compound. Does anyone remember? By any chance, we have done this in the solid state. Interstitial site. What is interstitial site? Yeah. What is interstitial site? Yes, anyone? Interstitial site. We have done this in the solid state. We have done this in the solid state. Interstitial site. Yes, Arjuna, Anmoldeep. In between space in crystal lattice. Okay, I get it what you want to say, but see, what is a crystal lattice? Look over here. What is a crystal lattice? Sarjana, crystal lattice means all the cube. Okay, cube, the single cube is a unit cell. Okay, single cube is a unit cell. In the solid state, we have seen the single cube, we call it as a unit cell. When you join all this cube, you get a crystal lattice. Okay, you get a crystal lattice. Okay, so crystal lattice is the collection of all the unit cell. Crystal lattice is the collection of all the unit cell. So you cannot say it is in between space in crystal lattice, but what I saying, I have got it. So it is in between space when you have all the atoms, like for example this, this diagram. So when you join all the atoms, obviously there are spaces left between. Yeah, so for example, Sarjana, yes, suppose I have a box, in that I have put a cricket balls. Yeah, let us take the example of this only. This is my box. Okay, blue are the cricket balls that I have kept in the box. Now isn't it obvious those are round, a box is square, so 100% of space cannot be occupied. Yeah, in a box you cannot keep spheres and occupy 100% of space. So the space that is left in between, that is called as interstitial site. That is called as interstitial site. That is called as interstitial site. Now some of the atoms like carbon, okay, hydrogen, nitrogen, these atoms get trapped in that interstitial site. Okay, which atoms? Hydrogen, carbon, or nitrogen. Okay, or nitrogen. Okay, why only they? Because their size is small. Okay, your space is not that large that all the elements will fit in. Only carbon, hydrogen, or nitrogen, generally they fit in that interstitial site. Okay, they fit in that interstitial site. Okay, they fit in their interstitial site. They fit in the interstitial site. Only carbon, hydrogen, and nitrogen. Carbon, hydrogen, and nitrogen. Yes, carbon, hydrogen, and nitrogen. Okay, so basically what happens, they get trapped in that interstitial site. Yeah, and the stoichiometry is disturbed. The stoichiometry is disturbed. Okay, and what happens due to that? Write down these 4 points. Due to that, write down these 4 points. What happens? They become strong. Yes, the remaining space is also occupied. They become strong. Hence their melting point increases. They become hard, they retain metallic conductivity, and they become chemically inert. Okay, come on, write down the 4 points, like a properties of interstitial compound. These are the 4 properties of interstitial compound. And what is interstitial compound? In your metal atoms, your hydrogen, carbon, or nitrogen will get trapped. Will get trapped. Okay, write down the properties, and after that, please write down these examples. After that, please write down these examples. And as I told you, you can see stoichiometry is disturbed. Okay, it can even go in the fraction. Write it down and done in the chat box. Write it down and done in the chat box. Done. Then we go ahead. Yes. Okay. Shall let us go ahead. Let us go ahead. So this was about the interstitial compound. This was about the interstitial compound. Now, yes, then there is a small part of alloy formation. Yes, what is an alloy? Can anyone tell me? What is an alloy? Yeah, alloy. Yes, what is alloy? And Sarjana, Sindhuja, Prashanti. What is an alloy and Muldeep? Alloy. Yeah. Alloy. Alloy. By the way, can we consider alloy as solutions? Very good, Anmoldeep. Can we consider alloys as solution? Yes, and can we consider alloy as solutions? Yes, correct. It is mixture of metals. Yes, it can be solid. So yes, alloy, we can consider them as a solution. Yes, like we have discussed, what is a solute? Yeah, how do we define a solute? Yeah, how do we define a solute? Yes, how do we define a solute? Correct. Present in small amount, less in quantity. Perfect. Okay. The one which is in the small amount is a solute. So similarly, if I am talking about alloy, the metal which is in small amount, I can call it a solute. The metal which is in more amount, I will call it a solvent. Simple. Okay. So alloy is nothing but the mixture of metal. Simply speaking, alloy is nothing but mixture of two or more than two metals. Okay. Mixture of metals. Alloy is nothing but the mixture of metals. Yeah. For example, brass. Yes, brass. You must have used it also unknowingly. Brass is an alloy of what? Yes, brass is an alloy of anyone? Correct. It is nothing but copper and zinc. Correct. Copper and zinc. Similarly, if I have bronze is an alloy of and Anmoldeep, Sarjana, bronze is an alloy of, correct, bronze, that is in the name, correct, copper and tin. Perfect. Copper and tin. Perfect. Copper and tin. Okay. Okay. So write down one statement. Okay. Alloy is formed only with the metallic radii that are within about 50% of each other. Okay. This statement is important. Okay. So alloy are formed only with the metal whose metallic radii. Okay. Whose metallic radii. Alloy are formed only with those metals whose metallic radii are are within about are within about 15% of each other. 15% of each other. Okay. You cannot form alloy of everything and anything. Okay. If the one atom is very small and one atom is very large, you cannot form alloy of that. Okay. Only if their atomic radii is comparable, only if their metallic radii is comparable, you can form an alloy. I want to write it down and done in the chat box. Write it down and done in the chat box. Okay, next we have is the oxoacids and oxoanions. Oxides and oxoanions of metal. Okay, next we have is the oxides of metal. Okay, next we have is the oxides of metal. Okay, so over here, what we have are the oxides of metal. Now remember one thing, as the oxygen going on increasing, okay, remember this, as we go from the left to right over here, come on, write down this can come which is basic, which is acidic, which is amphoteric. Write down this as example. Acidic character increases, basic character decreases. Acidic character increases, basic character decreases. Okay, per manganese, as the oxygen is going on increasing per manganese, yes, this is example for manganese, as the oxidation state is increasing, the acidic character increases. Yes, oxidation state increases, acidic character increases. So it goes from basic to amphoteric to acidic. Write it down. As the oxidation state increases, the acidic character, yes, the acidic character also increases. Acidic character also increases. Come on, write it down. Oxidation state increase, acidic character increase, and write down the example also. And tell me done in the chat box. Write it down and done in the chat box. Okay, and it's done. By the way, neat dates are out. I hope you know that. Yeah, it is on 5th May, but we are trying to finish our syllabus by January itself. Okay, we are not going to delay it. See, what is the plan? You know what we were thinking. Okay, it is not yet official. Okay, I'm telling you the insider news. Okay, what we were thinking was like we will try to finish the syllabus by January. Then you would be having your board exam in March, correct? So in Jan and Feb, we might keep the revision for your board exams. Okay, so that will help you in the board exams. Okay, then after that you have the NEET exam, that is on 5th May, correct? So that was the plan. Let's see, but we are going to try to finish it by January itself. Board starts in Feb. Is it in the last week? Are you talking about practicals? Board, when is the practicals then? I did not see the timetable yet. Practicals are in Jan. Oh, okay, fine. Okay. They did not announce the date. Fine. Okay. So, but NEET is on, they have announced it is on 5th May. Right, it is on 5th May. So you have ample amount of time. Yes. As I always say from the beginning, be consistent. Consistency is going to beat the talent, definitely. If you are consistent enough, if you study daily little by little, easily May is very far yet. Yeah, at least 7 to 8 months. You still have time. Getting my point, Sarjana, and yeah. So you have time in your hand. Be consistent. You know that syllabus gets over. That does not mean you will leave everything. Yeah. It should not happen like that. Be consistent and do it little by little. Little will make a mountain of scores. Yeah. Secure marks, secure, and ultimately you will have a bag full of marks. Yes. How's your physics and bio going, by the way? I hope it is good. Okay. Sure. Anyways, even I was going to even I was in the same boat. I was planning to go for zoology for the masters. Yeah. But good that I chose chemistry. Okay. See, and I am telling you now, if you become a teacher, okay, like this is an advice. If you are going in the teaching path of a career, do not become a biology teacher. Okay, do not become a biology teacher. Okay, now this is not a disrespect to our teachers. We have Mandivam or Vinod sir. Okay, because not because of that, it is because of demand. Yeah, chemistry is there in your NEET also. It is there in your JEE also. Getting my point? Yeah. So if you become good in chemistry, you can teach and you will have lots of students. So if you are thinking to make a career in teaching, chemistry is the best subject. Physics is difficult. Do not want to study that much. Okay. Biology is only remaining to the biology part is only for the NEET. But if you are good in chemistry, you are good. You will teach in JEE also, NEET also. Win-win situation. Yeah. Hmm. So Sarjana, if you are thinking of becoming a teacher, you know what you have to choose. Yeah. Hmm. Chalo. Let us go ahead. So, like, do you think yourself like you can become a teacher? No, no. Exactly same. When I was in 11th standard, the first thing I used to say if someone asked me that what you want to become, my first thing like I will not say that I want to become this. I used to say I do not want to become a teacher. I do not want to become a teacher. And ultimately, it's destiny. Life, a circle has completed and I have become a teacher. It is a good thing. Now I realize it is not a bad thing. Okay. Chalo, anyways, let us go ahead with the oxoanions and our oxides. Okay. So first, what are we going to learn? We are going to talk about an oxide of chromium. Okay. What is this? Which compound is this? Yes, Sajna. And which compound is this? Which compound is this? Correct. It is nothing but potassium dichromate. It is potassium dichromate. It is potassium dichromate. Correct. It is potassium dichromate. Okay. Now potassium dichromate. So you have different compounds to study. Okay. One of them is the oxides of chromium. That is potassium dichromate. Okay. Potassium dichromate. So you have preparation. You have properties. Okay. Just a minute. I have one PPT for that. Just a minute, everyone. Potassium dichromate. K₂Cr₂O₇. K₂Cr₂O₇. Potassium dichromate. Okay. Potassium dichromate. Now look over here. Potassium dichromate. Okay. So potassium dichromate, that is K₂Cr₂O₇. There are preparations of that. You have to study the preparation. You have to study the properties. Okay. So first, let us look at the preparation. How do we prepare potassium dichromate? Now I know the reactions are scary over here, but what you should remember is forget about the reactions, you remember the compound. Okay, forget about balancing, you remember the compound. For example, look over here. So I have FeCr₂O₄, that is nothing but my chromite ore. Yeah, Where did we study chromite ore? We studied chromite ore in the metallurgy, isn't it? It is a chromite ore. Why do we say chromite ore? Because it is the ore of chromium. Yeah. So over here we have taken, like, we are studying preparation of potassium dichromate from very basic. You have taken the ore. We are studying from there. Okay. So we have taken chromite ore, that is FeCr₂O₄. Now what is our compound? Our compound is potassium dichromate. We do not require Fe. So what I'll do, I'll react with base. Okay, I'll react with base NaOH or sodium carbonate, that is Na2CO3 and oxygen, and I'll separate the Fe. I'll separate the Fe. So I have separated Fe. Okay, and what I have got? I have got sodium chromate. So what I have done, remember like this, I have converted, remember by the name, I have converted chromite ore to sodium chromate. I have converted chromite ore to sodium chromate. Okay. Now sodium chromate, do I want chromate? No, I want dichromate. Yes, I do not want chromate. What do I want? I do not want chromate. I want a dichromate. I do not want a chromate. I want a dichromate. So over here, students, what we have a FeCr₂O₄, correct? So that is a chromite ore. From that we have got, what we have got? We have got our chromate. Now from the chromate we are going to get dichromate, because that is what we require. So I have treated it with acid. So since I treated with acid, your chromate now has become dichromate. Okay, so remember like that. We have prepared chromate. From chromite we have got chromate. From chromate we have prepared dichromate. And now again, do we want sodium dichromate? No. Simple. How can I convert it to potassium? I'll treat it with KCl. Simple. So your Na2 will be replaced by K2. Sorry, your Na2 will be replaced by K2, because Cl has more affinity towards Na than K. Correct? So as soon as I treat the sodium dichromate with KCl, Cl has an affinity with Na. It will leave K. It will go with Na. Yes, and you will get potassium dichromate. Simple. I repeat, I know this numbers very scary, yeah, but now for now write down the reaction at least once. Okay, do not write this one, write down this. Okay, this is there even in your NCERT. First step, second step, and the third step, treat this with KCl. Come on, write down it, Anmoldeep and Sarjna. So remember like that, and write down the statement also, this, the bold one. Conversion of chromite ore into sodium chromate, then conversion of sodium chromate into sodium dichromate, then sodium dichromate to potassium dichromate. That is how we prepare potassium dichromate. That is how we prepare potassium dichromate. That is how we prepare the potassium dichromate. That is how we prepare potassium dichromate. Come on, write down. Write it down and done in the chat box. Done. Okay, write down the third also, conversion of sodium dichromate into potassium dichromate. Okay, write down the third one also. Write down the third step also. Come on, write it down and done. Sarjana, is it done? And mold it and okay, sure. Let us go ahead. Okay, now there are some of the properties. Okay, there are some of the properties. Few we know. Have you ever seen potassium dichromate in your lab? Yes, Arjuna. What color is it? Like, let me show you. Potassium dichromate. Potassium dichromate. Potassium dichromate. It looks like this. It looks. It is orange red. It is orange red. Where did it go? Oh my god. Such a huge picture. Okay. It looks so nice. The color is so nice. It is beautiful. Isn't it? Orange red. Yeah. Orangish red you have is the potassium dichromate. It looks so nice. Isn't it? Yeah. So yes, it is orange red crystalline solid. Okay, then these are some of the properties that we are going to look one by one. Okay, then it gives chromyl chloride test. Now chromyl chloride test is what? It does not give chromyl chloride test. It is used as a catalyst in chromyl chloride test. Okay, it is used as a catalyst in chromyl chloride test. Okay, it is a test to know that if you have a chlorine or no. Okay, then it does react with hydrogen peroxide. Now this oxidizing character important for organic chemistry. It is a good oxidizing agent, a strong oxidizing agent. With respect to organic chemistry, what is an oxidizing agent? Yes, what is an oxidizing agent? Sarjana, what is an oxidizing agent? Gives oxygen to the compound. Correct. It gives the oxygen to the compound. Yes, it gives the oxygen to the compound. Yeah, correct. It is something that gives oxygen to compound. Okay, so these are some of the properties. These are some of the properties. Okay, so if you heat potassium dichromate, simple. If you heat potassium dichromate, please write down this reaction. Potassium dichromate, it will turn into chromate. It will turn into chromate and chromic oxide. Write down this reaction. If you heat potassium dichromate, it will decompose into potassium dichromate will decompose into potassium chromate and chromic oxide. Potassium chromate and chromic oxide. Okay, it will decompose into potassium chromate and chromic oxide. Yeah, it will decompose into potassium chromate and chromic oxide. Someone write down the reaction and done in the chat box. Potassium chromate and chromic oxide. Potassium chromate and chromic oxide. Okay, now when you react same thing with the base, okay, when you react the same thing with the base, again you can check. Yeah, what are you getting? See, it is simple. Okay, it is simple. Okay, everywhere you are reacting, what are you getting again? Chromate ion, chromate, chromate. Simple. Okay, so remember like that. Remember like that. Okay, remember like that. So like what is the oxidation state of Cr in chromate? Yes, what is the oxidation state of Cr in chromate? Yes, Sarjana and Anmoldeep, Sindhuja. What is the oxidation state of chromium in chromate? Yes, it is. Yeah, In the dichromate, what is the oxidation state? Check. In the dichromate, what is the oxidation state? Yes, and correct. Anmoldeep, Sarjana, check in dichromate oxidation state. In dichromate, Anmoldeep, in dichromate K₂Cr₂O₇, is it? I am talking about single chromium, Anmoldeep, not both the chromium. I am talking about single chromium. Yes, it is 2, no? Single chromium. I am talking about single chromium. So what I am getting? Let us check. So it is 2x minus 14 is equal to 0. So 2x plus 14 minus 2, that is 12. It is 6, correct. And did you take it as minus 1? How did you get 3? So it is x is 6. Okay. So remember like that. Okay. Remember with the
So for
help of.
chromate 6, sir, then you asked for dichromate.
So
For
for
dichromate,
dichromate,
it will be 2x is equal to 6, so x will be 3.
2x is equal to 6. How? Oxygen is minus 2, no? Oxygen is minus 2, no? So 7 2 is minus 14,
I
isn't it?
forgot O7, sir. I
Acha.
still took it
Okay.
for 4.
Acha. Okay, no issues. Okay. So it is plus 6 and plus 6. Okay. So remember with the help of oxidation state, it will be easy. Okay, it will be easy. Okay. So that is how it behaves with alkali and with the heat. Okay. And again, if you look at this, same reaction. Same reaction. Okay. For the alkali, it was behaving like that. For the base, you have to just reverse. For the acid, you have to just reverse the reaction. Yeah, you have to just reverse the reaction. What is happening if you have reacted with base? You were getting orange to yellow. Yes, if you write it down, if you want orange to yellow, if you are reacting it with base. Yeah, and if you again add an acid, you again add an acid to that. Yes, base will get neutralized, again yellow to orange, isn't it? Again yellow to orange, again yellow to orange. Simple. Okay, write down this one reaction. So orange, yellow, yellow, orange, it goes on happening. Okay, orange, yellow, yellow, orange. Okay, you can change the color again and again. You can change the color again and again. Okay, done. Okay, let us continue this from next lecture. And I wanted to talk about this. How many of you attended weekly test? Sarchna and Prashanti, yes or no? Come on in the chat box. Did we attend the weekly test? It was CBSE based pattern this Sunday. Sarchna attended and Anmoldeep has not attended due to exams. Prashanti, and you have not also attended. Prashanti, what about you? Anmoldeep has not attended. Ragul, so do not do like that. Attend it. Okay, like see, I am telling you, just give your half an hour. Just give your half an hour. At least check what questions are. Yeah. If you get less marks, I'm not going to shout at you or something, but at least attend it so that at least some revision of yours will happen. Yeah. And why we have kept CBSE pattern, because it will help you in your CBSE paper how to write down the answers. Yeah. You will have the habit of writing theoretical answers. That's why we have kept the CBSE paper also. And if you look at it, the paper was very easy. Like, look at this. Look at this question. This was so easy. Yeah. Electronic configuration of nitrogen. Okay. We had kept all the questions easy, medium, difficult. electronic configuration of nitrogen. Yes, so simple. Yeah, it was the first because atomic number of nitrogen is 7. Yeah, simple. Then look at this. Okay, I wanted to discuss this question also. Let us discuss this also. Then we'll do the class assessment. Okay, look at this. Which of the compounds have net zero dipole moment? Over here, I am telling you the answer XCF6. Why? XCF6. Why? Okay, because okay, XCF6. Tell me what will be the geometry of XCF6 with the help of VSEPR. Come on, Sajna, Anmoldeep, and with the help of VSEPR, solve this XCF6. Yes, with the help of VSEPR. VSEPR. Come on, tell me. What is the geometry of XCF6? Do you remember, Sajna, how to do that? Hmm. Yes, correct. And yes, Sajna, what did you get? Hybridization, at least tell me hybridization. Yes, correct. And Sajna, what is hybridization? And Moldeep, do you know how to solve it with the help of VSCPR? You have not attended too many sessions. Yes, obviously. See, look over here. Xe. How many valence electrons we have? Anmoldeep, Sajna, in this we have 8 valence electrons. Correct? It is the noble gas. It has the 8 valence electrons. So I have drawn the 8 electrons. 3, 4, 5, 6, 7, 8. Okay, I have 6 fluorine, fluorine, third fluorine, fourth, fifth, sixth, and you have a lone pair. So number is 7. Okay, so 7 means you have 1s, 3p, and 3d orbitals. sp3, d3 orbitals. So it should be PBP, but it is not PBP. It is distorted octahedral. It is distorted octahedral. It is an exception. Okay, it is a distorted octahedral. So distorted octahedral, and all the elements are same. So they cancel out each other's magnetic moment. They cancel out each other's dipole, and hence they have zero dipole moment. They cancel out dipole, each other's dipole. Yes, if it is opposite, it cancels it out. Okay, if it is opposite, it cancels it out. and hence it is 0. Okay, hence the answer is B. Is it clear, Sajna, Prashanti, and is it clear? Okay, so do not miss the weekly test. Okay, do the weekly test. If you have doubt, we will discuss, like I have planned to discuss weekly test also in every lecture. Okay, after your weekly test, so give the weekly test. This time you will be having, I am telling you, you will be having P block. Sorry, not P block, the D block, till what we are covering. Okay, first 2 sessions, D block. Okay, we will give the D block of first 2 sessions. Okay, now let us go ahead now. Okay, let us do the class assessment. Enough, we have done enough today. Okay, just a minute, just give me a minute. Assign you the class assessment, just a minute. Till then you think of this answer. Till then you think of this answer. Till then you think of this answer. One of the question in the weekly test. One of the question in weekly test. Okay. Anyone answer for this? Any answer for this? No? Arjuna? Any answer for this? Correct. So ammonia, no. pH3 will not dissolve in water. That is given over here. Why it does not dissolve? That is the question. Correct. Correct. Your ammonia, no. It forms hydrogen bond with water. Your ammonia forms a hydrogen bond with water. Okay. Hence they get dissolved. Okay. Your ammonia dissolved, but pH3 cannot form hydrogen bond with water. Okay, so hence it does not get dissolved and it is fast. It forms a bubble. It forms a bubble. Okay,